Hello everyone, this is Udaditya again from TechSpark bringing you another session covering data engineering question and answers. In today's session, we're going to talk about structured streaming API in PySpark. So before starting off, as usual, I'm going to give a brief introduction of myself. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with our comprehensive course covering all the necessary topics of data engineering. So structure streaming API is a huge advantage on PySpark in order to deal with the real-time data or near real-time data. So this real-time data is nothing but the continuous flow of the data, and the upstream application from where the data would be sent could be anything. Now, in the previous Kafka session, I did mention that Kafka is one of the most popular tool to carry the data, the real-time data from the producer to the consumer. And the Kafka topics are the vessel to carry the data, right? On the producer side, there would be some HTTP server or any API ingestion who's literally pushing the data into the Kafka topics. And on the consumer side, there could be any other API, be it Python, Java, or PySpark, who would simply be pulling the data or pulling the streamline data from the Kafka topics and then do its processing. So structure streaming is one of the most popular tool or one of the most popular phenomenon in the PySpark to handle this large amount of streaming data that is continuously flowing in. It is scalable and fault-tolerant stream processing engine built on top of Spark SQL. It allows processing real-time data stream using the same declarative APIs as batch processing. So what it means is that as similar to the batch processing, where once we read the data from any file or any batch, it is presented to us in a tabular format, right? And then using the Spark SQL functions, we can do any sort of processing we want, be it aggregation, join with the other data, as well as writing to tables or any files. Those are also allowed in the Stream API. So the structured streaming API works in a way, it will create a tabular version of data or tabular format of data. And then once that is created, you can simply do all the similar processing as we do in the batch processing. So let us look at the key features of the structured streaming. One is the unified API. Uses the same data frame and the dataset APIs as batch processing. That is, it is very easy for us to process the data even if it is flowing continuously. All we have to do is just present it in a tabular format or in term of a data frame or a dataset. Second one is the fault tolerance. Uses checkpointing and write-ahead logs to ensure data consistency. Checkpointing simply means that we are going to drop the data or write the data to the disk each and every point, so that if anything goes wrong from the upstream application or if the job fails, in that case, it will have the data as a backup. So whenever the next time the job resumes, it will understand the last data that it read using the offset parameter, and then it will start ingesting from where it left off. So that's how the fault tolerance is achieved. Third one is exactly once processing. Ensures messages are processed only once in an end-to-end pipeline. So that is basically done through offset only. Exactly once processing means that I have a data that is lying in the Kafka topic, and on the consumer side, if my Spark job is running, so it shouldn't make the mistake of repeating the same data or ingesting the same data twice or more than twice. Okay, so it should have the data loaded only once. Even though there is like two data of the same offset in the Kafka topic, it will only read in only once. So that is the third point. Fourth is the scalability. Automatically scales to handle large data streams. As you know, that PySpark or the Apache Spark works in a distributed engine ecosystem. So obviously this scalability is something that the Spark already has built in. And the fifth one is the continuous and micro batch mode. It supports low latency micro batching and continuous processing. So we can configure our streaming job in a way, if we want, that we can continuously ingest the data, say for each and every 1 millisecond, or if we want in suppose micro batches, like each and every hour it should ingest the data. That configuration is also available in Spark Structured Streaming. So we can kind of tweak the settings in a way, or while writing the data wherever, be it in the console or any NoSQL DB, we can tweak that configuration. So now let us look at the different streaming modes in Spark Structured Streaming. So there are typically three modes. One is the append, second complete, and third is the update. And let us look how it works, how each and every mode works. So append mode, only new rows are added to the output. It is, quite self-explanatory, right? Appending means it will simply keep on adding the new records at the end. This mode is efficient and works well for event-based streaming, like Kafka messages, logs, sensor data. So obviously, if I don't want to miss any data, so even if there is any update or if there is any deletion, all I want, whatever the data that is there sitting in the Kafka topic or any upstream application, I want to ingest the same. Okay, and I want to just keep on adding it. Whatever I want to do with this data, that will be discussion for the later on. But I want to simply keep on adding the data, that is whatever I'm ingesting. So usually from the Kafka topics, whenever we ingest the data, we put it in append mode so that each and every data or each and every offset in the topic can gets loaded into our system. So use cases is when the data is not updated, appending new records to a database or a Kafka topic. So whenever we are loading the data, but we are sure that the data is not updated, neither we are doing any sort of aggregation in our Spark job. In that case, we can use the append mode, and it works only for non-aggregated data. So if you are doing any aggregation, in that case, the append won't work. Complete mode is the entire result table is updated and written to the output sync. If you remember, in the Spark batch processing, when we write to a file, there were different modes like append and overwrite. So if we do overwrite, in that case, the whole data gets deleted and the newer data gets written. So it works something like that. So whenever we do some aggregation, then for each and every batch, the data can be totally overwritten. For aggregation, the previous records need to be updated, right? Because whenever, suppose I'm aggregating through a key, and the key is, say, by department, I'm aggregating all the salaries. Okay. And say if there are like three department, each and every department getting 10,000, then the average would be 10,000. Okay. Or if I do a sum, in that case, it will be 30,000, right? Whenever a new department comes in, sorry, whenever the same new record with the same department comes in, the 10,000, in that case, what will happen? The summation should be 40,000. So it needs to be updated and also get overwritten. I don't need the 30,000 anymore, because now it is 40,000. Now I know that. I mean, that's the simple calculation, right? So in these cases, complete mode can help us. Use cases, as I just mentioned, when performing aggregations, that it word count, sum, average, and also works well for batch-oriented output things like memory console, Delta Lake. Delta Lake is totally and entirely a different thing. I won't be discussing over here. Let it just put it for another session. And memory and console simply means I'm just showcasing into the RAM. Okay, I'm not writing it to anywhere. Third one is the update mode. Only the modified rows are written to the output, more efficient than complete mode, and sends only change records instead of rewriting the entire table. So in this case, what will happen? So based on the key, whatever updates are being done, so only the newer records, newer records will be written to the table. So it's more efficient than the complete mode, because whenever we are handling aggregations, we would want that for each and every batch we keep the updated value, and it may so happen that I want to evaluate the updated values of the aggregation based on some time. Say for example that I'm calculating the averages or say summation of each and every sale for an e-commerce, right? So in the morning I have some data aggregation, or the total sale has been showing up. Okay, and in the evening the sale is changing. Obviously there would be more sale and the aggregation would stacked up, right? But if I want to analyze the sale that happened in the morning, in that case, I would want the morning data, the morning aggregated sale. If I use the complete mode, in that case, at the end, I'll be getting only the data that came in the evening or at night, for the full data. But sometimes for analysis purpose, it is also required for the clients to check the individual batches to understand how their industry or how their whatever be the purpose is performing. Okay, so use case when aggregations need to be streamed in real time works with aggregations that do not require a full table update. So as it's quite self-explanatory, right? If I do want a full table update, in that case I'll use the complete mode. In that case it will simply write off all the previous aggregations and write the new ones. But if I want to keep all the batches, all the batches of the aggregated output. In that case, I can use the update mode. Okay, so this is how the structure streaming works, and now I'm gonna show you one live example. All right, and I'm gonna be ingesting data from Kafka topic. Let me just, okay. Yeah, I guess my screen is now visible. So this is the Spark structure streaming code that I've written. Now I will be ingesting data from Kafka topics. Okay, to run or to produce any Kafka topic, Docker desktop is necessary. So not, I mean, it's not like absolutely mandatory that you need to have Docker in order to install Kafka, but you can do it in the Windows machine as well. But that is kind of like an obsolete technique. Usually with the Docker, it's much faster, much easier, much simpler. So that's why I have one Docker container, one Docker desktop opening, and over there the Kafka container is running. So what I'm gonna do, I'm gonna create a producer. So this is a Kafka console producer. So I'm gonna be pushing messages by myself, right? So that is the job of the producer. So this is actually the command to create a producer. So I'm using a topic called test, and my bootstrap server is where the brokers are located. So it is nothing but the local host 9092. Now everything is prepared into a Docker compose YAML, and use, and over there all the configurations are set. Even though I have to use the topic name while creating the topic, I have to use the other properties such as the pass key true. I want to incorporate key in my messages. As I said, like the Kafka has this key value combination, so I'm gonna put both the key and the value. And key is, even though optional, you can also choose to put only or push messages as value only, but for the moment I will show both so you can have a good understanding of how it looks. Okay, so now this is the command to start off any producer. I will just press enter, and you have to make sure that your Kafka server is up and running. So that is the reason in the Docker desktop my Kafka server is running. So how can I literally confirm that? So let me just get out of this terminal. Okay, now if I just do Docker PS, in that case it will show all the processes that is running. So if you can see in the container, I have the Docker entry point over here. So these are the container, right? So one is the Kafka, the other one is the Zookeeper. Zookeeper, as I mentioned in the Kafka session, that it is kind of like a master daemon where it kind of checks whether all the brokers are alive or not. So it instructs the Kafka what needs to be done in case of any failure or in case of any issue is incurred. Okay, so my Kafka and Zookeeper both are running. So all the processes that are running, all the containers that are running, basically you will see under the Docker PS. So now that I confirm that the Kafka is running, so I will create a producer again using the same command, and my producer is up and running. Okay, so now the producer is up and running. What I'm gonna do, I'm gonna run this Spark job, and I will also walk you through the code. But first, let me just run the code and show you how the output looks like. What I'm trying to do is that I'm gonna read the key and the value from the Kafka topic, and then I'm going to simply display the key and the value parameters in my console. Okay, so my job is running. It has just commenced. So once it is fully functional, then I will start pushing data from the Kafka topics. So we'll have to wait a bit for this. It takes a bit of time. Yeah, so my Spark job is running. So remember one thing, it's not like one time run, it is still running. If I want, I can simply, so I'm using the PyCharm ID. If I want, I can simply stop or then stop and rerun. But this is live and running. Okay, now I have to go to my Kafka topics. So this is the producer, right? I'm using the test topic, and now I'm going to write some messages using the key. Okay, if you look at the command, the pass key property is true, and also the key separator I'm putting as colon. So the delimiter is colon. Whatever I put on the left side of the colon, that is my key, and whatever I put on the right side of the colon, that is my value. So 1 is the key, Uday is the value. I'm putting it as 1 colon value. Now this is one message that I'm sending. I just put enter. Now let me look at the console. Okay, now I can see that it is coming, the key and value. This is from the Spark streaming job. From the Spark streaming job, it is showing one and Uday. Now, as and when I will be sending the messages, this is how accordingly it will show up over here. Again, there's the next message I'm going to be putting, say two, and I'm going to put, say, John. Okay, now let me try this. It should be key John and sorry, key 2 and value John. Yeah, there we go. The next one has also come up. So as and when I'm pushing the data into the Kafka topic in real time, it is coming in. It's not like I'm writing any file, then I'm placing the file into Hadoop or in some cloud storage, and then I'm reading the data over here, right? So this is absolutely real time. I mean, if I want, I can put a processing time as 1 millisecond, and then I can simply, obviously I have to type that first, even though I know that's not possible for me. So let's try out another message, and this time I'm not going to put 3. Let me just put 999, something like this, and say whatever, David is the name that I'm putting, right? It should show up the same into my Spark job. There we go. Okay. So this is one example of how we can ingest data from the Kafka topic and showcase into console. We can put the data into any NoSQL database such as Cassandra, or we can store the data in any file, be it Parquet or anything. Okay. So now, since I have shown you how it is working, I'm gonna stop the job. I'm gonna stop my producer. I'm just gonna put Control C. That's it. Let me minimize this. Now let me walk you through the code what I have written. So first of all, you have to make sure that your Kafka container is running. It is from Docker, or maybe your Kafka is running in any cloud. But it's better that if you're using for yourself, for practicing, it's better not to use the cloud, because any cloud you go, be it AWS or Azure or GCP, it will charge some money. Okay, that is the very reason why I'm showcasing here using the Docker desktop. Using the Docker desktop, it's absolutely free. It's very simple, just a few commands you have to run, and then you have to build a YML file, and then simply your Kafka is up and running in Docker. Okay, so now let me walk through the code. So first of all, as usual, I'm going to be creating a Spark session. So the Spark session, that it's similar the way we created when we were dealing with the batch data. Okay, I believe I showed you in the Databricks. In the Databricks, Spark session is already created and it is available in the name of Spark. So that is the reason I didn't recreate it over there. But whenever you're developing a script from scratch, be it batch, real time, anywhere, you have to provide the Spark session. Without the Spark session, it is not possible for you to create data frame or kind of like deal with the latest the Spark 2.0 architecture. So this is the command to create the Spark session. That is the builder, then the app name. Then in the master, we have to put local star. Local star means whatever the number of CPU cores available in my system. So use all of them. Okay, then there is these configurations which are essential to deal with the real-time data. This one, the jars package, this specific jar is required to run or to ingest data from Kafka using Spark. Then this configuration is for checkpointing. So basically in this location, the intermediate results will be stored. So any case, if anything goes wrong, in that case, my job can simply read from the next offset. Okay, then the bootstrap server. So bootstrap server is local 9092. Okay, so when I produce the producer, I mean when I started the producer, in that case you can see the bootstrap server is provided as local host 9092. So basically 9092 is the default port where the producer would be running, sorry, the brokers would be running. So the same server I have to use over here in order to connect with my Kafka topic, and obviously the Kafka topic name. The topic name has to match, and also the broker server, the bootstrap server, has to be in sync. Okay, so now the schema that I'm using over here, okay, so this schema is obsolete. Sorry, I'm not using this schema. This schema I would be using if I had been ingesting any JSON format data. In that case, I would need to pass the data. But for the moment, I'm not complicating things. So let me just remove this one. and this is also not required. Okay, so next is I have to create a read stream API. What is read stream? So this read stream API, it's a keyword basically that is provided by the Spark. So this will help you to read the real-time data, not only from Kafka, or it could be from anywhere. Okay, so you have to provide the format over here in the format method where you would be typing Kafka in order to read from the Kafka, and then again the Bootstrap servers and the Kafka topic to which you will be subscribing. So you can see the Kafka.bootstrap servers. I'm using the Kafka bootstrap server which I have defined over here. That is the localhost 9092. If you want, you can simply hard code the same over here. Then the subscribe. Why subscribe? As I said right in the Kafka session that whoever be the consumer, he needs to subscribe. That is the publish subscribe model that the Kafka runs on. Okay, so whoever is pushing the message, so he's like publishing the message, and whoever is pulling the message or consuming, so that means I have to subscribe to the topic first in order to get all the information from the topic, right? If you're watching Netflix, if you don't subscribe to Netflix, obviously Netflix won't give you their content. You won't be able to watch Squid Game, or you won't be able to watch Stranger Things, anything, right? So it's a similar thing. First I have to subscribe to the topic, then I'll get access to the data that is sitting on that topic. Then there's another option, that is to define the starting offsets. Not actually define, putting the option, meaning this starting offset, so this won't change, but over here I can put earliest as well instead of latest. So if I put earliest, what will happen? So suppose my Kafka topics has data say 2 days prior, and when I just ran the job, I started pushing the message, and those messages were only coming in into my console when I ran the job, right? But if I put earliest, in that case all the other messages that I pushed say 2 days before when the topic was created, okay, so all those data will also be coming, which I don't want. So that's how something I can tweak. If I put earliest, in that case all the historical records will also be coming. Okay, now, so this is through the readstream API. I'm providing all these attributes. My data frame is loaded. Obviously, I have to use the load method. So once the data frame is loaded, after that, I'm using a select expression to only specifically get the key and the value. Okay, so the reason why I'm putting key as a string and value as a value, because they come as binary data. Okay, so if I try to run it again, let me just omit this one. Okay, I don't want to convert them in string, and see how it looks like. I'm gonna comment this portion out, and I'm gonna run the job again. Right. All right. So my job has resumed. Let me again go back to my terminal and start the producer again. Okay, this time I'm going to be sending the same message, 1 : Uday. Now let's see what's showing in my console. See the first batch. Look at the key. It is showing 31, and look at the value 75, 64, 61. Is this the same key value that I sent? No. Obviously no. It was 1 : Uday. But if you look at this one, so this is because it is being shown as a deserialized format. It is the serialized format, not deserialized. Deserialized means not in the binary format, converted. But it is not converted. It is the raw serialized data that you're seeing. So that is the reason that you're not seeing the proper value. And in order to see the proper value, you have to convert them into string. Otherwise, it won't be usable for us. And if you see the other columns as well, so basically just look at this select expression over here. I'm just choosing the key and the value, but when I try to load the whole data frame or showcase the whole data frame, in that case you can see that there are other fields as well, such as topic name, partition, offset, timestamp, and the timestamp time. So if I just try to sync up my metadata, so the topic name is obviously test, right? That's what I put it over here. Then there's the offset is 23. So what is offset, right? For each and every message, that would be kind of like an ID or something to signify that which record it is. So over there, before this, actually there were 22 other records which have been already sent. So if I go to my terminal or my producer again and try to send the second message, say to David. Okay, just look at the offset over here. It would be now 24. Okay, so it is like incrementing one for each and every record, and this will actually help us in achieving the fault tolerance whenever our job is failing in between. So 23 is read, so I'll start reading from the 24. Right. So similarly, timestamp is when this record was read. So this can also help us in analyzing the data in terms of event streaming. All right, so I'm gonna stop this one. So now my data frame is loaded, and this is the reason that I have to convert the key and the value as a string in order to understand or in order to view them as human readable. And last but not the least, so I have to use a write stream. So this is the only difference between batch and the real time. In the real time, I was using the show method, right? Using the show and put the number, only that many records were coming. Now there is no show. Obviously you cannot put number because data will be ingested in real time, so whatever data comes in, that will be shown in the console. So the output mode is append. So this is one of the three modes that I just discussed: the update and the complete. Obviously from the Kafka topics, I want my data to be added at the bottom every time, and the format console means that wherever I'm running the job, it should show me only there. If I had done a Spark submit in my cluster, in the cluster console only, it would be showing. It would not be storing the data or writing the data in a disk or in a database. And start is obviously when I start the job. Okay, and I will only stop my the job will only stop whenever I will terminate it. So that is the reason it is using the query await termination. Okay, this method will not terminate your, I mean, auto terminate your job. It will wait for any sort of manual intervention in order to stop it. Okay, so this is how the code goes. Read stream is the API through which you would be reading from the Kafka topic, and write stream is the API through which you will be writing to anywhere, be it database, be it file, be it showing in the console. Write stream is the one, and start is basically when you start the job. For any real-time job, for the structure streaming job to commence, you have to write the start method. Otherwise, it won't start at all. It won't. The job will simply fail. Okay. All right, so this is all about structure streaming. So this is just the tip of the iceberg. There are so many things we can do in the structure streaming API. There are like windowing, aggregation, joins, all of these are possible. Just reach out to TechSpark to get to know more about the data engineering course, where we cover almost all the tools such as the Spark, Hadoop, Hive, AWS with hands-on coding and real-world project. And obviously you might be wondering that how did I set up docker desktop, how did I create the Kafka containers, what is this YAML file through which I can provide all the Kafka parameters. Everything will be shown in the course. Everything will be covered, and obviously I will show you how to create clusters, Hadoop clusters, Hive database, everything in local. No need to you don't have to pay anything whenever you're creating local clusters or anything. You won't be using the cloud at all, because for practice purpose, obviously you won't be using your money. So all these things will be shown in the or covered in the course. Just reach out to us, reach out to TechSpark, and just signing off from this session, hoping for all you to reach out to us as soon as possible. Thank you.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpark.